All right, and we've got the last talk of the day, Richard.
Thanks, Siri. Hi, everyone. I'm just going to share my screen, which will, I think, be blank to begin with. Thanks to the Talmo organisers and to Siri for asking me to give this talk just along the corridor from me at Warwick. I'm going to boot up my PowerPoint presentation. So, yeah, my name is Richard Lissaman. I lecture maths at the University of Warwick, and I'm going to be talking about how I've been using Desmos Classroom. So Desmos has been mentioned earlier today. And it's a little bit different to some of the other sessions that we've seen because I've been using this particular package in live teaching sessions. So I'm not necessarily thinking about resources or formal assessment or things that students will use outside of the live teaching sessions generally, but actually during the sessions. And I am thinking about traditional lectures here. So you know, it's very much it's actually the same cohort of students that Siri described earlier, 350 first year undergraduates. Modules where you have 3 lectures per week, you've got, you know, a lot of content to get through. So really you can only spare a few minutes in each lecture for quizzes and interactivity. So I found Desmos Classroom to be very suitable for this kind of situation. My background is that I did have a spell lecturing at Warwick sort of 20 years ago, but I spent 15 years working for MEI, Mathematics in Education and Industry, which is a UK-based charity that supports mathematics in schools and colleges, does a lot of work with teachers and students, promotion of mathematics and further maths, especially in England. And through that, I became aware of things like GeoGebra and then later on Desmos. I must admit I have used GeoGebra much more than Desmos, but around about the time of the of COVID, I know that MEI was moving a lot of its support online and making good use of Desmos Classroom. They found that they could kind of recreate some of the things that they would do in the classroom with students within Desmos Classroom because it's got really nice functionality and it's quite easy to use. So this is what I'm planning to do in the time we've got. Well, first of all, I'll tell you what Desmos Classroom is. I'm not really sure how many people will know what it is already. I suspect that many of you will have at least heard of Desmos and perhaps used Desmos Calculator, the graphing software, as we saw Siri demonstrate earlier, but perhaps not Desmos Classroom as such. So within Desmos Classroom, you can construct sequences of on-screen tasks and students can then engage with them. And I've used them, as I say, during face-to-face lectures and also during online lectures during the pandemic. I've lectured a kind of abstract algebra module where the students meet groups and rings for the first time, and an analysis module, so where they meet sequences and series and continuity and differentiation and so on. I've only ever used it with first year courses, and I'll say something about that later on, but I imagine this is where it would be best used. I found it to be a very useful tool, very versatile, very quick and easy to use, and it's made a big difference to engagement in lectures. Prior to this, I was using Vvox, which is kind of a polling plugin for Moodle, which the University of Warwick subscribes to, and I found that kind of useful, but slightly limited. So I was aware of Desmos Classroom from my previous job, so I kind of switched to that in preference to that. And yeah, as I say, my modules, it's the same cohort that Siri described earlier, 350 students. But I think what I'm going to describe would work equally well in much smaller groups. So my plan then for the time we've got is I'm going to get you hands-on with the Desmos Classroom activity. And then I'm going to try to demonstrate live authoring, a bit like Charlie there, doing something on the fly. Hopefully that'll go well. But I'm trying to demonstrate how easy it is to use. Hopefully you'll believe me once you've seen me attempt it. Then say a little bit about my own reflections on using it, you know, where I found it useful, where I found it limited. And then I think accessibility has been mentioned, but Desmos is really good for accessibility. It gives students lots of different ways to engage with the sort of interactivity, the things they have to enter. And there's some more advanced features. There are lots of stuff that I don't know about this, about Desmos Classroom. I've only really been using it seriously for a year or so now. This is what would happen in a lecture or in a live session. this will be a test for how many people are actually there, actually still here, or wandering away from their screen. But if you could go to that URL and type in that code, I'll be very grateful. Now, I am now hoping that I will see people appearing in my, sorry, Zoom tends to take over your whole screen, doesn't it? And you can't find any other windows underneath it. So I'm just trying to find where you all are. Okay, got you. Right, okay. I can see that there are people appearing in the room. Actually, what I'd like to do is just show you what I can see. So I've got access to the so-called dashboard for this particular activity that I've set up. It's paused at the moment, so none of you will be able to interact with anything, I don't think. And I've also anonymized the names, so it replaces your name with, as it says here, the name of a notable mathematician. You can see that this is my view, so I've got this sequence of things to look at. Probably far too many. We won't get through all of them, don't worry. And at the moment,
Richard, sorry, can I interrupt you there? Can we have the code again, please?
Yeah, so if I click here, it's that. So student, sorry, I should have put this into the chat, of course. So
hang on, I'll do it.
I've got it. It's in there now. Yeah.
All right. Thanks.
Okay, so yeah, wow, we've got a good number of people here, as you can see. Now, I think at the moment it will be paused for you. You're going to have to sort of keep flicking between two windows, which might be a little bit tricky, but hopefully you'll get the gist. I think it's important that you can see what I can see as the session leader. So the first thing I'm going to do is unpause this. And at the moment, you are restricted to go on the first 3 screens. So you should now be able to interact with the first screen. And you can add a point to the diagram, which is a map of Europe. I didn't really know exactly where the Talma audience would be. I opted for Europe in the end, but maybe if you flick back to the view that I've got on the shared screen in Zoom, you can see that I'm able to see which of you have completed this task. I can click on a particular response to see what that particular person gave as their response. I've also got a way to overlay the responses. So actually, I can see that most of you are in the UK, if not, well, a few people elsewhere. Okay, now you are able to move on to the next slide. So hopefully it's clear what you need to do to that. There's a right arrow somewhere. And you can now tell me how you're doing on this Wednesday afternoon at 4:30, having watched 3 sessions already. So what's your energy level like? And I've just been marking exams, so I won't fill this one in myself. And again, we can overlay that. That's very nice to see. You're doing pretty well. And you know, this is sort of, you can use this for icebreaker activities and so on. You can get students to draw things or whatever. So the next thing I'm going to do is I'm going to enable you to have a look at a couple more slides. So I've now freed up the next 2 screens where you can ask the students what you can get an idea of what they sort of whether they're likely to ask questions and explain ideas. But all of it, I should point out, I've not actually created any of these slides myself. I've just nabbed them all from the Desmos website. So you can, there's a really easy way to share your materials. In fact, if you have an account with Desmos and you create one of these, it is then automatically available to other people to search. So that's the way the whole thing works. So it's very easy to pick things up from what other people have done and so on. Okay, so that's an idea of what we might do with ice breaking. I'm now going to move you on to slides 6, 7, 8, and 9. So I'd like you to move to there actually, starting with slide 6. And what you'll see there is an animated graph. You can see there's a point moving along the graph of a function y equals f of x. It's moving into x equals 1 from the left. And we're asking what y value is the dot getting closer to as x approaches 1 from the left-hand side. So I can see what you're doing there. If you switch back to the Zoom view, you can see that I can see all your responses. I can see who's completed the task here with the ticks and so on. One thing I can do is I could actually choose to give any of you some feedback. So I can click on a particular obviously I wouldn't do this in a lecture, but I could click on a person and type them a message and give them some feedback. But clearly that will depend on the number of people in your session. So I'll now just invite you to move through the next few slides, 7, 8, and 9, where you're going to explore the relationship between one-sided limits and continuity. So I can see people are making very good progress. Most of you are now on slide 8, and a few of you moving on to slide 9. Yes, it is. And another thing you can do is you can get it to automatically display sort of 2 or 3 answers from particular students on the same screen. So all of those sort of things are possible. I'm still exploring some of the more advanced functionality, but it is possible to show other students' responses in this. Okay, so now I'm just going to let you free a bit more. I'm opening up some more. I can see you're all very fast, which is very nice to see. There's a few more slides there open up until slide 15, I think. And what you'll see there is a few things where the interactivity is a little bit different. So you have to draw some things. You can drag some points around in graphs and so on to get correct answers. Yeah, so not dissimilar to what we were seeing from George earlier, creating functions with particular properties in their graphs. Okay, so I'm hoping you're getting some sort of idea of what sort of thing is possible when you create your slides, your activities in this kind of Desmos Classroom activity. You can see also later on, you can sort of ask the students to reflect on what they've done and what they found difficult and how confident they felt with their answers. Again, I don't really use that in lectures, but you can imagine that with smaller groups, that could be a very useful thing to do. I think what I'm going to do now is I'm just going to bring you back into just to pick out a few other things that are possible. So I think I'm going to ask you to look at your Zoom view now rather than your browser with your particular instance of the activity. I was thinking a little bit about the kind of course that Siri's been delivering, the vector calculus course, and some of the things that you could do here. So yeah, so you can see here what we've got is we've got a parameterized curve. So S is the parameter, and it's parameterized as x equals s, x equals s squared, y equals s squared. So it's going from 0, 0 out to 1, 1. And we've got this tangent vector here. So differentiating the 2 components will give us 1 and 2s. And we've got that tangent vector appearing at the point s. So one of the things we could ask the students to do is to create the unit vector for that tangent. So that would mean just dividing through by the modulus of the vector, obviously. And what I found was when you get students to do things like this, they they could instantly kind of work out how this interface is going to work without very much training at all. So I'm going to try and modify this t so that we've now got a unit vector. So I'm just hitting divide there, and it makes me a fraction. I'm typing square root for the square root, and then 4s squared. I don't need any multiplication symbols there. And then I'll divide this one through by the same thing. 1 plus 4s squared. And then you can see I can then go over here and interact with this, and I can see that I've now got a unit vector rather than the actual tangent vector. Thinking about some other things that you might see in a course like series course, I guess. So here we've got a picture, and we can interact with this. So we've got some level sets. We've got grad f. I'll make this full screen, actually. It might be a bit easier to see. So we can see at this point, grad f is pointing in this direction. So we get some sort of idea of what the relative heights are of these contours, and we can ask the students to order these in that way. Having done that, we can then ask them to find a point where we'd expect grad f to point directly downwards. So that will be a point like this one, where we would see if we move down, we're going up through the heights here. And then we can get them to test their answer. So we could have them able to drag this around so that we can see what grad f looks like at various points and test their answer. And then this one is just a drawing exercise, so drawing grad f at this point. So that's not going to, sorry, I've got a teacher display here, so I'm not going to be able to interact with that, but they can draw in an arrow on top of that. And then they could test their answer to see whether they drew the correct direction for grad f at that point. And you can, it's true that Desmos is very limited. Well, certainly in terms of 3D, as Siri said earlier, you need to be very brave to take that on. But I think Desmos is generally much more used in schools and colleges, and so it might have more of a reputation for dealing well with the kind of mathematics you would see at that level. But it is certainly possible to do other things here. So here we've got a vector field, and we're looking at div and curl at various points. So we could get students to predict what those values would be and then test their answers by moving this around. So we can do things like this. This is actually very similar to what we saw from George earlier as well. We've got Taylor polynomials, and then getting students to respond regarding what the error looks like at various values of x, and so on. These are some of the things that I set up for abstract algebra. Generally, I'm not using graphing facilities for this. I'm just using this as a way for students to kind of do a quick quiz on things that I've been talking about in the lecture. So generally what I would do is I would think about what my lecture is going to consist of, and I like to have it so that these appeared about halfway through the lecture. So I think about what I'll be talking about then. And this is really a kind of were you just listening type test. So they circle, that's not right, is it? They circle the values here. We've got card sorts. So here we can attach these cards together so that we're looking for things that are subgroups and things that are not subgroups. This was one of my first attempts at a question, so I just wanted them to sort of have pictures of all the things we were talking about. So what definition or theorem does this represent? So very simple multiple choice with just an image. What does this represent? What does this represent? You can put tables in, so you can sort of lay things out using tables. I had them reconstructing definitions. So here's a card sort where they have to get the definition of continuity in the right order. Again, I'm thinking about we'll be introducing that definition. I would ask them to do this at just a few minutes after we've been discussing the definition. Some simple yes/no questions. In the abstract algebra course, thinking about dihedral groups, how many symmetries are there, draw them, and then so again, and then this is a kind of continuity type activity where we have to make the delta smaller so that it works for that epsilon, and then we can reduce the epsilon and understand that we need to make delta smaller to get the required delta for that particular new epsilon. and so on. Other card sorts in the abstract algebra course, pictures of functions, again in the abstract algebra course, and so on. Okay, so hopefully that gives you a good idea of the kind of things that you can create here. What I'd like to do next is show you how you would create something like that. So I'm now going to go into my own Desmos account. I'm hoping that you can still see my screen. So that's the activity that we just had. You can sign up for this. It's completely free. So I'm going to create a new activity. I'm going to call this demo, and we'll press create, and we go into this kind of authoring environment. So you can see I've got my first slide here, which is blank at the moment. I've got lots of different things that I could add to that slide. I think first of all, I'll start with a card sort. So I've clicked on card sort, and it will now ask me to add either text or images or graphs. So my graphs can be images, they can be cards, they can be text, which you can do some maths formatting on as well. I'm going to choose images. I've created these images earlier. So this is my continuity proof images. So I created these just using, well, just LaTeX within PowerPoint and just screen grabbed them. So I pick my image, it makes the card. I want that to be a large card. Now I'll add another image, which is going to be the next part of the definition. I'll just add one more. I'm going to make that into a large card as well. And then one more. So there's a bit of work you need to do beforehand to get this set up. And now I can preview that, and I can see that I've got these, and that's looking okay. That's the right size. It takes a little bit of experience to know what the right size is for your screens when you're cutting your graphics and so on. I can add an answer key. So I can say, well, what's the correct order for these cards so that it can provide feedback to the students and so on. So there's my first, that's my first slide done. Continuity definition. And now I can add another slide, and this time I might do something with a graph. So I've clicked on graph. I'm going to put some things on the graph. So let's go for f of x equals x squared. Let's put a point on there. Let's create some sort of, let's imagine we're exploring differentiation. So we're going to put h as 0.5. We're going to allow the students to move this from -1 to 1 with a step of 0.1, let's say. And then we'll create the point 2 plus h, comma, f of 2 plus h, which we can't see on the screen at the moment. There it is. And then let's create a line between them. So I'll need to give them names for this. So we'll call that point A, call this one point B. And let's create the line segment from A to B. So you need to get used to all this kind of notation, obviously. What's wrong with that? Point, okay. You click on the left here to sort of change some of the properties. So I want this to be a line and so on. And then I could maybe calculate the gradient as f of 2 plus h minus f of 2 over h. You can imagine you could do a lot more with this. So it will show me this is 4.5. I could put that value on the screen by just creating a point. So let's create the point 4.4, and let's give it the label of G. So you can see I can display that point, the value of that gradient, and I can actually get rid of the point completely. So it's just giving me that value, and I could call that gradient or something. So I can do all that, create that, and then I could ask them to do something with it. So what is the value of gradient when h equals? So I can do some maths formatting here. So h equals, it's pretty primitive, but you can get sigma and you can get integrals and so on and fractions, but it doesn't have the full range of maths notation that you might want. In particular, Greek letters are missing. And then I can say, okay, I want a maths response, and I can preview that. And you can see we're very nearly getting towards having a full question there. Another thing that I can do, which is really useful, is if I can just grab somebody else's GeoGebra. So this is a website where I found lots of 3D stuff. Probably you've encountered this before, Siri. So here's a picture that I like, created in Desmos Calculator. It's 3D, so who knows how much work has gone into that. But I can now, on my third slide, I can have this graph, and I can paste in the URL for that. And I've now got that as part of my slide. And again, I can start to put in, do this, etc., and preview that. And you can see I've now got something that I can move around here with cross sections. But I think the point I'm trying to make here is that I found this very, very easy to use. And to the extent that I would often create the activity sort of on the day before the lecture or on the day of the lecture, even, in those hour or two before the lecture where you're thinking about what you're going to be doing in a lecture, I would be creating the activity at the same time, because of course you never quite know where you're going to be in a lecture course and how fast you're going to go, or what things the students will ask you about and the things you want to emphasize. So what I found was that this was a very flexible tool for creating things quickly on the fly. So it's not something you would use for rigorous assessment, but you could create useful stuff very, very quickly, close to the time of the teaching session. Okay, so I think I can see that I'm getting near to the end of my time now. So I think what I'd like to do is come back to PowerPoint and just say a little bit about my own experience of this. Well, first of all, the students had no problems accessing it. So most of them will be there with a mobile phone, as you'll be well aware if you've lectured students and see the phones there. And when I said to them, go to this URL, I think about 60 or 70% of the people in the lecture theatre would do that. And then some of the others who didn't do it were looking over the shoulder of others with a laptop who were doing it. I found the authoring to be very quick and easy, and as I've just said, I often put together things very last minute using this, knowing that it was an easy to use tool whereby I could do that very quickly. I found the whole Desmos software generally very, very intuitive. If you think that you expect something to happen in a certain way and then you try it, it normally does, and you're kind of away without having to sort of read up lots of documentation. I think it increased engagement. I haven't got any sort of formal feedback like Siri had, but the students did seem to look forward to it. Some of them mentioned it in the written feedback that we asked them for. And I would say, halfway through this lecture, we'll be doing a Desmos Classroom activity. So, you need to be listening so that you can answer the question to that. So quite often I would set questions which were just, what did I just say? And I found that kind of, students were quite happy to answer questions that were very close to things they'd just seen. And if I didn't have a Desmos Classroom activity, generally a student or two at the end would come and ask me why not. So they did seem to like them very much. Limitations. So yeah, I mean, it's not as powerful as something like GeoGebra. There's lots of things it doesn't do. It doesn't do 3D very well, as we've discussed already. But it's surprising what you can do with Desmos. I think most of the stuff that you will find if you search for Desmos activities has been designed for use in school and college, but you can find lots of other stuff that might be used at a more advanced level than that. Yeah, but I can't imagine that you would be able to use this much outside the scope of first year modules. So I haven't really thought too much about that, but it just seems to lend itself quite well to some of the things that typically students will do in first year university mathematics. I found that the documentation for Desmos was not quite as good as for GeoGebra, so I found I had to hunt around a little bit more. Most of the times the things that I tried did work, but on the occasions where the thing that I tried didn't work, or I just couldn't find the button, it took a little bit more hunting around to find what to do as it would have for GeoGebra. And then the existing activities that are out there, you can kind of pinch. Most of those are you'll find that have been designed for use in school and college level maths. Yeah, so you can have scoring and feedback. There is something called the computation layer, which I've not really explored very much, but you'll see that for each of these elements, there's this, you can add a script to it, which means you can pick up the variables from it, you can send it to other components on the page and so on, and you can check variables and provide feedback. In fact, I think I've got something here which is a bit more like that. So I just kind of stole this from somebody else's presentation. So here you can give the you've got to give the volume of this cylinder. So I can ask it to check my work, and it gives me a nice animation there. So hopefully this is, yeah, and it tells me that this is right. You can put video content in, so you could ask the students to watch a video. I found a really nice activity somewhere where this was obviously set up for some students to work through in their own time, I think. And you can see there's a slide here where they've been given various videos to watch, so they can sort of click through and it'll switch the video in and out, and then afterwards they're answering questions about what they've just seen in that video. So you could set up sequences of work for students to do, you know, before a lecture perhaps, or before a teaching session, so that they can come in with a bit more prep as to what's going to happen. So yeah, I think I'll finish there because I can see we're out of time, near the closing time for the sessions this afternoon. But hopefully I've managed to convince you this is something that's worth looking at. I found it to be good fun, and it's the students seem to like it too. Yes, you can bring all the students together to a particular slide. So that's using this pacing facility. So I can also pause, so stop everybody from working on something and just get their attention using this pause facility. But yeah, I can move them forward as well as allowing them to sort of move forward themselves to a particular slide. Yeah.
I think there's also a question about how much text can you throw at students per page?
Well, I've never sort of come up against the limit for that, but I was careful to try to not put too much text on a given page. I mean, I have tried this on a mobile phone, and it does seem to respond extremely well to a mobile phone. But of course, you need to limit the amount of stuff that you're putting on a page and the general busyness of it. But it's very nice to design these slides. You can you know, you can move things around. So I might prefer this to be on top of this, and you can generally sort of find a way to display what you want in the best way. It's very easy to just switch things around.
Okay. I have a little question about you know, when you were showing the dihedral group thing, and people were invited to draw some lines. How is that marked?
Yeah. So I mean, I've been using this in a live teaching session. So generally what I would do is I would talk through the answers to these things afterwards. So I wasn't really, I'm certainly not using it for any kind of formal assessment.
It's I mean, does it do the marking or not?
It can obviously it can't mark a drawing really, but it can mark
Okay,
numerical responses.
I understand.
Not algebraic responses, but numerical responses.
Right.
Yeah.
Understood. Okay.
Yeah, but I haven't really investigated that side because I was using it during live teaching, so I knew that I could talk to the students about what they'd just done immediately afterwards.
I've got another question from Joe Fang. Can students save their progress?
Well, they don't even need to have an account for this, so they can sign in as a guest. And I would have thought most of the students who participated in this were doing it that way. So they were kind of they would put their name in. I would anonymize that, but there was no record of them engaging with it on any server. But what you can do is you can make it so that this URL persists after the teaching session. So when you sort of publish this activity, you can decide whether you want it to be exist for 2 weeks or a month or a year, I think. So I was able to put the links to these on the Moodle page. So anybody who hadn't got worked through everything during the lecture could go back and do that. And I encourage them to go back and look at these again as part of their revision, actually. And then I'll be able to create new URLs for next year if I'm lecturing the same course again.
Okay. Right. I think yeah, that's fun. I had fun on your demo thing. Yeah, I think a lot of people did too. Okay, I guess we could wrap it up here. If you have further questions, you can always put in the chat, and then yeah, Richard will follow that up. But thank you to all the speakers today.